OpenAI recently released the latest and greatest large language model, O1, and this thing is absolutely crushing benchmarks, and in general, it's just an incredible step forward for generative AI. And I'm sure you've seen dozens of people talk about O1 already, testing it out, explaining how the chain of thought works, or maybe just playing around with it. But today, I've got something for you that is completely different than anything else you have seen on O1. And I can't believe that people are not talking about this because there are straight up things that you cannot do with O1 that are crucial for developing AI agents or complex AI applications in general. Hold up. I just dropped a truth bomb on you there, and so you deserve to know exactly what the heck I am talking about. In the beta preview of O1, there are going to be a lot of key features that are missing from the model, including tool messages and function calling, which are both absolutely necessary for AI agents. What this means is, unlike other models like GPT-4o, O1 by itself will not be able to interact with the outside world with things like APIs or web search. You need function calling for that. And this is seriously a bummer because you can't use the now most powerful LLM for most AI applications. Just take that in for a second. It sucks. But I have come to the rescue because I have custom coded function calling for O1. You heard that right. I have replicated OpenAI's tool calling. And let me tell you, this setup supercharges O1 and makes it an incredible AI agent. The ridiculous reasoning capabilities of O1, combined with the ability to interact with any API, is a game changer. I'm going to show you exactly how to do it. And the best part is you can use any LLM with this setup. And so if there's ever another situation in the future where you have a powerful LLM that doesn't have function calling, you can plug that LLM in just like O1 so you can instantly use it to create AI agents. So let's go ahead and dive right in. I'm going to show you exactly how to implement this, and then we'll test it out to see how powerful O1 really is as an AI agent. All right, so when I say I'm going to show you exactly how to implement this, I mean we're going to code this thing from scratch. You can see what I have here is just the skeleton for a main function. And we're going to walk through step by step, setting up all of our tools, implementing the prompting and the custom tool calling for O1, and then also the UI with Streamlit so we can interact with our chatbot in our browser. And so the first thing that I want to say is that there is going to be a link to all of this code in the description of this video in a GitHub repository. And so you can just go ahead and steal it from me if you want to start using it right away without having to worry exactly how everything works. Because I don't want you to have to be very technical to get a lot out of this. And so I'm going to go through all the code, but don't worry if you don't understand everything. I'm not going to go in super great detail because the main thing here is just to show you quick what I built and then test it and show how powerful O1 is as an AI agent. And so if you download this code from the GitHub repository, you'll have this script right here, which we'll go through all the code for in a bit. You'll also have a requirements.txt file, so you know all the Python packages that you need to install in what version, and then also an example environment variable file, so you know exactly how to set up your environment, just like mine, to run this with no hitch. All right, and with that, we can go ahead and start coding our custom function calling O1 AI agent. I am absolutely stoked for this. So the first thing that we want to do here is import all the Python packages that we need for this agent. And this kind of reveals a lot of the services and libraries that I am using for this agent. So I'm going to touch on this really quick. First of all, I am using Asana. Asana is my favorite task management platform that I use every single day. And so this agent is going to help me manage all my projects and tasks in Asana. So that's what we're going to be doing for all of our tools. And I'll show that in a little bit here. We're also going to be using Streamlit for our user interface. It's a really nice and easy to use Python package for UI, and it works well with AI as well. And then the last thing to call out here is I'm going to be using LangChain. It is my favorite Python library for making it very easy to work with LLMs, and it develops a lot of things for you so you don't have to reinvent the wheel with things like prompt templates and chaining, all that good important stuff with LLMs. And so with that, we can move on to some of the code. And so the first thing that we're going to do here is load our environment variables, which includes the large language model that we're going to use. I would recommend O1 Mini. And then also, this is going to be explained a lot more later, but you're going to optionally be able to show the AI's thoughts as O1 is thinking to itself when it is reasoning about all the tool calls that it is making. And so if we turn this off, all that stuff is going to be hidden behind the scenes and not shown in our user interface. If we turn it on, then we can actually get an insight into how O1 is reasoning about everything, which is super cool. I'll explain that more in a little bit here. The next thing we're going to do is define all of our configuration for Asana, including our access token, and then we can get into defining our tools. Again, this is going to be a bunch of different Asana tools. I've actually used GPT-4 to help me create all these functions. So it's really simple, mostly boilerplate API code for Asana. So I'm not going to go over it in detail, but just know that these are going to do a bunch of cool different things in Asana for me, and I'll bind these as tools into my Asana chatbot that's going to be using O1. That's going to be my AI agent. And so the first function here, the first tool is going to be creating a task in Asana. Then we're going to have one to get our projects in Asana, another one to create a project, another one to get all tasks within a project, one to update a task, such as the due date or maybe the description of it, one to delete a task, and then that's actually the last one. So just a bunch of simple little functions here that will help me manage my tasks and projects in Asana. And the last thing that I'll do here is create a binding here, a mapping from the name of each function to the actual reference to the function object in my Python script. And this is what we're going to use to bind every single tool into the agent so it can invoke it. And so that's what we're going to do right now. But it takes a little bit of setup to actually get this ready, because the first thing that we need to do is create a list of descriptions that's going to tell our AI agent exactly when and how to use each tool. And the way that we're going to do that very neatly is with the docstring that we have for each tool function. And so this is what a docstring looks like right here. And for every docstring, you can see that I give a description of this function, which will tell it when and how to use it, an example call, all of the arguments in great detail that it needs to supply to invoke the tool, and then also what it can expect as a return, so it can reason about the output of this tool. So all this is packaged together neatly, telling the agent everything it needs to know about every single tool, and that is combined together into this neat little list of tool descriptions that we're going to bind into our first prompt to the LLM to help it understand everything about these tools. And we'll get into that in a little bit as well. The next thing that we need to do is we need to define exactly how we expect O1 to return a response to us, because we need a specific format to be able to process its response, all the tool calls that it's requesting, and also all of the arguments for each tool that it wants to invoke. And so we're going to be doing that through a couple of classes that we're going to embed into the agent as an output parser. And that's a LangChain concept that I'll explain in a little bit when we set that up. And so first of all, we have a class that defines how we expect a tool call to be formatted when the LLM requests to invoke a tool. And there's two parameters that we need. First of all, the name of the tool, which is just a string, and then also the arguments, which is a dictionary. And this is going to be a dictionary that maps to all the specific arguments that we need to invoke a tool, like the ID, the data, whatever it might be. And so if it needs to invoke this function, it would say task GID colon is this ID, data colon is this dictionary. And that's how we would call update Asana task, just as an example. And then at a higher level, we have the actual response from the LLM. And so when it gives us a response, when we invoke our chain, that is the O1 agent, it's going to give us a dictionary response that has two attributes. The first one is a list of tool calls, which can be empty. And this is just going to be a list of the class that we just defined above. So the name and arguments for all the functions that it wants to invoke. And then the second thing is the content. And this is whatever text it actually wants to return back to the user. Usually this is going to be empty when it wants to invoke tools, but if it is done invoking tools or decides it never needs to, content is going to be filled in here with the response to the user. So with all this set up, we can now finally create the prompt that is going to tell the O1 agent exactly how to work with this custom function calling setup. And so I have actually spent a lot of time pouring into this prompt and making it really good. It's pretty detailed here, so I'm not going to go into it greatly, but basically it just describes to the LLM how to work with these different schemas, how to work with the custom function calling and when to invoke it, how to work with that. I give it all the descriptions of the tools using the doc strings that I described earlier. And then finally, I tell it about the idea of giving thoughts. So basically, a thought is going to be an AI message that starts with thought colon, and it's going to be an internal dialogue that the LLM has with itself. And so it's not to be shared with the user. It's just meant to give the LLM context for itself about what happened when it invoked a tool or any errors that it needs to correct when invoking a tool. And so that show thought environment variable at the top, when it's set to true, that's actually going to be displayed to the user. So we can actually go into the LLM internally and see all of its thought processes as it's invoking tools and reasoning about the outputs of them. But if it's set to false, then all of these messages that I'm talking about here that start with thought colon are going to be hidden from us. And so we'd have a regular chatbot where we're not seeing the inner workings of its thought processes. And that is honestly my favorite part about this whole setup. I'm kind of proud of how I implemented all of this because it makes it really easy if we want to see exactly how it is invoking all the tools and correcting itself when it needs to do so. So yeah, really cool stuff. And so with that, we can get into our functions for actually prompting our AI agent. And so the first thing that I'm going to show you here is a nifty little function that adds one of those thoughts to the conversation history. And so using our Streamlit session state, we're just going to append that thought as an AI message. But again, we're describing in context for the LLM that it actually wants to ignore these thoughts as far as providing an answer to the user and just use that for its own internal dialogue. And then if we want to show the thoughts based on that environment variable, we'll display it to the UI as well. And so with that, we can start our prompt AI function. This is where we do all of the work of actually interacting with our agent. We have a couple of things for error handling that I'll get into in a little bit. Basically, we want to make sure we don't loop forever. Sometimes the LLM will hallucinate and do that, and so we have a little fail-safe here. But the first real thing that we want to do in this function is define our LangChain chain that is going to be our chat OpenAI instance that will reference the O1 model. And so we're using a JSON output parser using that tool call or response class that I defined up here. And what this is going to do is basically enforce that the output we get from the O1 LLM is going to be a dictionary that has exactly these values and nothing different. So we're going to be guaranteed that if the invocation of the LLM does not fail, that means that we have a list of tool calls and a content string. That will be guaranteed. And so going forward in this function, we will just assume that we have those two attributes available and that they are formatted in a valid way. And so the next thing that we want to do is actually invoke our chat. And we're going to do that with the Streamlit session state, the messages that we're building up that will maintain the conversation history. And if there's any kind of exception getting a response, like if it didn't give the right output format with the tool calls and the content, then we're just going to recursively call the function again to prompt the AI. And it looks like I have an extra old parameter here. I'll fix that after. But anyway, just a little bit of recursion to basically have the AI redo its answer. And most of the time, it'll get it right the second time if it actually fails the first. But O1 is pretty good at not doing that. The next thing that we're going to do is check to see if we have any tool calls. And so again, tool calls at this point is guaranteed to be an attribute of the response because we are using our JSON output parser. So if we do have any tool calls, then we're going to loop through every call that we have, get a reference to that function, that tool function that we want to invoke, and then actually invoke it with the arguments that O1 has decided it wanted to call with, like the due date and the name of the task to create, whatever that tool argument might be. And then if we fail to invoke the tool for whatever reason, like maybe the arguments were invalid, then we're going to add a thought to the LLM and basically tell it that you tried to invoke this tool, but you failed to do so, and here is why. And we'll include the exception message in the thought. And so that way, we're going to recursively call prompt AI. It's going to basically retry, but with this added context, so it knows exactly what it got wrong, so it knows how to correct itself. And this is very, very powerful. And from my preliminary testing, it works so, so well. So I'm really excited to show this to you because we basically just add this thought and then use recursion to try again. Now, if we don't fail to invoke the tool, then we'll print the output and then add a thought, so giving context to the LLM that, hey, you invoke this tool with these arguments, and here is the response that you got back. And so that way it knows how to reason about the output to ultimately give an answer back to the user. Like, yes, I did create this task, or yes, I did create this project, or mark this task as complete, whatever it might be. And so then the next thing that we're going to do is add this tool call to the list of tool calls. Because one thing that I've noticed that even O1 likes to do, even though it's a really powerful LLM, is sometimes it'll hallucinate and try to make the tool call a second time when it's already made the tool call and it should be just giving its final response to the user. And so I've added a little bit of error handling for that just to make this whole AI app even more robust. And this works super, super well as well. Because basically what we're going to do is this entire tool calling right here only happens if the tool call that it wants to do is not already something we have invoked. But if it is something we already have invoked in this else right here, we're going to add a thought that says, I already called this tool with these arguments. And this is the response that I already got. And so then we'll go through, recursively call prompt AI again, and then make sure that we're not making the same tool invocation over and over and over and over again. And so this catches any loops that we might have in our LLM. And that is very, very important for this custom function calling implementation. The next thing that we're going to do is at the end of this function here, we're just going to recursively call prompt AI. So if we've invoked tools at this point, we've invoked it successfully, added the thought of the result of calling that tool, then we're going to recursively call prompt AI to either make the next tool call that might be necessary or produce that final response for the user. Like I said before, something like, yes, I've created the task for you. And then the very, very last thing that we're going to do in this function is if we don't have any tool calls at all, so this is if we have tool calls, then we do all this good stuff. If we don't have any tool calls, then we're just going to return the AI response directly, because at this point, it's a simple back and forth between the user and the AI. No tool calls are necessary, and so we can take the content from the AI response and just spit it back out to the user immediately. And so that's what we're doing here. And so with that, was definitely in depth, but that is everything that we have for this whole custom function calling setup and what we need to do to actually invoke the AI and handle any tool calls. And so really quickly, I'm going to go over the main function, and then that is it. So I appreciate you bearing with me. I hope that this is providing a lot of value to you. Even if not all this is making sense, I hope you can see how truly powerful it is and how much error handling and robustness I've added into this to make it a really powerful AI agent, even though I can't leverage all of the power of OpenAI's native tool calling. And so yeah, going to the main function quick here, we're just going to add a title to our Streamlit UI and then also initialize our session state, the messages, which is going to, as I described earlier, start with just one human message. And this is basically the replacement for the system message because I tell the AI, again, you can't have system messages with O1, it's one of the limitations. We're basically telling the AI who it is, giving it the current date, for some extra context. And then here's where we inject all that tool text, that big prompt that I showed earlier that describes to the LLM exactly how to work with this custom function calling setup. And so all of this begins the conversation. So it has that in mind with the rest of the requests from the user. The next thing we're going to do is just display all the current messages in the UI that are being managed in the chat history through the messages session state. And then we're going to prompt the user. So creating this chat input where we get the requests from the user. Every time we get one, we'll add it to the UI and also our session state. And then we'll prompt AI, we'll call prompt AI to get the response, and then also display the AI's response to the UI and add it to the backend session state as well. And that is everything. We have now fully coded our Streamlit UI, the custom function calling, interaction with the O1 agent, and everything. So we can go over to the terminal now and actually run this so we can interact with our AI agent in the browser. All right, here we are in the Streamlit UI for my O1 custom function calling AI agent. And now I'm just going to play around with this and show you how powerful O1 really is as an agent. And so the way that I started this, I'll just show you really quickly here. I went into the directory that you can clone from the GitHub repository, and I ran the command streamlit space run space O1 AI agent.py. And so this instantly started up this URL here and opened it up in my browser. And so now I can go ahead and talk to my agent. And so there's a ton of different things that I can do in Asana here. I'm just going to pick a couple of random things. And also I have the thoughts turned on. So I'm going to show you in depth what the AI is thinking about as it is processing my requests and fulfilling them. And we'll see how good it is at reasoning. This thing is just incredible from all the testing that I've done already. So the first thing that I'm going to ask it is create a task in my coding project to code thing one by Sunday. And so this is actually more of a complicated request because at this point it doesn't even know the ID of my coding project. So it has to fetch that and then it has to go and create the task, reason about the date that it's due, give a title for it and everything, and then return the response back to me. So we have our first thought here. It called create Asana task, but the project is wrong. It needs to give a project ID, not just a name. And so it's definitely not right. And also the due date parameter should be due on. So there's a couple of mistakes here, but it got the error, and now it's reasoning about how it needs to actually fix it. And so this time, when it gave a second shot, it decided first it needs to call get Asana projects. And this is exactly right. This is just beautiful, the reasoning that it has here, because now it's going to actually be able to get the project ID, not just some arbitrary name of the project that it made up. So it started with a hallucination, but then it was able to correct itself, which is just awesome. And I know that maybe I should probably format this JSON a little bit, but I don't want this to be like super, super massive. And mainly what you want to focus on here is just the thought and then what it did. So now it called create Asana task. And the arguments this time included a project ID and a task name and then the due date. So it's almost right here. This is going to actually create the task in Asana, and I'm actually going to show this here. I'll go into my Asana, and sure enough, I've got code thing one due by Sunday. So this is working really, really well. But at first, it didn't actually have a due date of Sunday. It had a due date of today because the due date parameter is supposed to be due on. So what happened is it saw that it actually didn't make the due date right. And so then it decided it needs to call update Asana task, changing the due date to 2024-09-22. And sure enough, it calls it, it updates the due date successfully, and now we have the right due date that we saw in Asana right here. So one simple request here, but it had to get its bearings about what are the IDs for projects, how should it update the due date, and so it had to reason about itself actually quite a bit here. So if I scroll up and go through all this, like there's like a lot of thoughts that went on here. And honestly, it's not the cheapest, but this is actually O1 Mini. This is not the most powerful model because that is more expensive and takes longer. I just wanted to go with the mini one here. And yeah, at the end here, we get the answer that the task is created. Absolutely perfect. So all that internal dialogue, it figures out what it needs to, and then it creates the task in me. It is just so good. And now I'll say, okay, now I actually want to delete it. So now we'll remove this, and then I'm just going to test with one more thing that's a little bit more complicated, and then we'll go from there. And I think, yeah, that'll pretty much be it. So yeah, boom, there, the task is gone. We deleted it, and we'll get a response. So yeah, first it just has the thought, and then yep, here's the actual answer. So if we had thoughts turned off, it would have just told us this, which is absolutely perfect. So now here's the next thing that I want to do. I want to have it create multiple tasks for me at once. So I'll say create 3 tasks for me in coding. And I'll say, we'll say build the next big SaaS, make an AI pet startup. Not the perfect grammar there, that's totally good. And then I'll say code the next moon launch. All right, let's go. And so at this point, it's a little bit more of a complicated request because it has to reason about creating the first task and everything it might need to do to correct that, and then create the second one and then the third one. So it's going to take a little bit longer. So I'm going to pause and come back once this is complete. All right, and this was actually quicker than I thought it was going to be because this time it already remembers now the ID of the coding project. So it doesn't have to go through the whole process again of looking it up and correcting itself. And so this was pretty quick here. It called each of the create Asana tasks for each of these tasks. It had the thought of that it already called it. So it looks like it maybe tried to call the same task creation again, but it caught itself with that error catching that I have, and it figured out it doesn't need to do it again, and then finally it returned the response back to me. I'll go over to my coding project, and sure enough, we've got all of these tasks ready for us. It looked like it messed up a little bit because it said the due date is today. Well, actually, maybe that's fine. Is that fine? Because did I say it was supposed to be Sunday? It looks like it tried to make the due date of Sunday, but it failed, so it didn't correct itself there. So it looks like it's not perfect, but it is definitely doing an amazing job. And we could obviously just correct it very, very easily and say something like, hey, you didn't make the right due date, just update it quick, and it would do so. So I'm leaving this in here to show that like it's not 100% perfect, and you might want to experiment with this a little bit more if you want to take it up, but it is definitely working really, really well. And this setup is just so, so cool, and O1 is amazing. All right, so that is a wrap for our custom function calling O1 agent. I hope that you found this super, super useful because without it, you're not actually able to create AI agents with O1. Hopefully in the near future, once we get out of beta for O1, fingers crossed that is soon, we'll be able to use OpenAI OpenAI's direct tool calling and not have to have a workaround like this. But in the meantime, this is a really powerful way to start using O1 right away for agents. And also, it's just a really cool implementation to learn more about how function calling actually works under the hood. I don't know exactly how OpenAI does it, but it's going to be something like this because obviously this works really, really well, especially with O1 having such good reasoning capabilities and it being able to correct itself so much. So that is everything I got. I got the code in the description as well if you want to take a look at everything we just made. If you found this valuable, I would really, really appreciate a like and a subscribe. And with that, I will see you in the next video.